Hi, this is Ashish R. Bedekar, and welcome to my podcast, The ARB Show. I'm thrilled to introduce today's guest, Atharva. Atharva is a first generation entrepreneur working in clean and green tech. He is a co founder of a company called Greyeast, which is focused on wastewater management. Over to you, Atharva. Look forward to your vision for Greyeast and understanding from you about importance of wastewater management, what are the business opportunity, and what are the top 5 trends in wastewater management. All to you, Atharva.
Thank you. Thank you very much, Ashish, for inviting me here. It's a pleasure to speak for your podcast. And okay, let me just start with uh, a bit of a background of actually how we started this company and why we started this. So back in my thesis days in IIT Mumbai, I was working on a very interesting technology called photobioreactor. There we were growing algae in a controlled reactor system, and that we were using to sequester some chemicals or some gases. Basically, it was for growing a certain algae which can yield some useful pharmaceutical products. So from there we kindled that idea, why not, if we can grow some biological species on a particular a substrate. So basically substrate is nothing but the chemical compound on which the organisms grow. So here it is the chemicals which are present in the wastewater. So that's how we kindled that idea, and that's where we began thinking about building our business. And since then, it's been 7 years. We are into core biotechnology. We are located in Vasai currently, and yes, our name is Greyeast Technologies Private Limited, just for the clarity. Uh, and our major forte is, we believe that the final problem of human race, that is how to treat water in industries, how to degrade chemicals, is not by using chemicals. So many industries, they actually use chemicals to treat chemicals, and then there is a byproduct which is again a chemical, and then you have to degrade it again. So that is something which is not sustainable. So we thought, I think biology is something which is best and which is intelligent and which is self-sustaining. So we use different organisms, mostly bacteria, which are grass grade, or you can say human friendly. They are not pathogenic. We develop, isolate and fortify these bacteria and target particular element in the water which causes problems, such as benzene compounds, aromatic compounds, pesticides. All these are organic compounds, and major problem is reducing these compounds into the most suitable form, that is CO2. That's how we target. So CO2 is the most the basic form of any carbon compound. So we want these organisms to eat away the chemicals. That is the whole idea behind it. If we eat something, it is digested, the problem is solved. But if we treat something and convert it into something other form, which is also a chemical and not a biomass, then the problem regenerates itself. So that's about the company, and we have been working for, I think, mostly chemical industries in MIDC areas. In not MIDC actually. We are now internationally also well connected. We are supplying our products internationally now. Also, we are connected with government agencies, and that's how it's been fantastic. Last 7 years, we have been able to impact this foreground on a very large scale. As of today, when we are talking, I think we are already treating. In next 1 hour, our technology might have treated 30 lakh liters of water already.
Fantastic.
And
So,
saved few million rupees. Yeah.
yeah. So I was reading somewhere there is a term called bioremediation. So what you're
Exactly.
working, is this a part of that?
Yes.
Okay, okay. Because I was reading where use of fungi, mushroom specifically, I think some
Right.
kind of
Right.
oyster mushroom for treating
Right.
oil waste. So
Right.
they kind of saying that it is untreatable. So oil, unless it degrades, you either use
Hmm.
some chemicals to degrade it. But what happened is, on a pile of such oil-rich soil, they kind of grew mushrooms and they kind of degrade it. So
Right.
fantastic. So
Right.
essentially, it is close to, you're kind of using nature to solve such major problems. And so is
Exactly.
Greyeast a B2B kind of play, or is it a B2C play, wherein, let's say, housing societies or apartment blocks can use this, or it is a product to be used by municipal corporations?
So currently it's B2B. I mean, we are not. I mean, we cannot supply this to actually a one customer, a family. That product we are coming with. So that also I will discuss what exactly the opportunity lies there. But majorly we are B2B. So currently we are targeting industries. Industries, it's a huge problem of degrading the chemicals. There are industries which actually pollute the rivers and lakes on a very larger scale, which is not even imaginable to civilians who live outside. We are actually not aware of the big problem which we are sitting on currently. So along with industries are one market, that is B2B, and other one is we are also doing STPs for societies for sewage treatment. So we call that as a sewage treatment, and one is our effluent treatment, which is specifically for industries.
Got it. So when you say effluent, I was reading somewhere that amongst the top industries which consume water, paper industry is supposed to be one of the top
Yes.
industries which consume. So anything which consumes will also, pollute, right?
Yes.
So similarly,
Yes.
I'm told textile is another industry sector which consumes a lot of water. And when you talk of effluents, I'm told sugar factories, sugarcane factories, wherein you kind of, crush and process sugarcane juice to make sugar. That's again a big effluent. So essentially, these are the kind of, areas where your technology is used. So okay, so that's great. So let's I'm really keen to hear from you what you feel are the top 5 trends specifically in wastewater management.
Okay. So let me go with the experience of how we actually started and where we are seeing the problem is boiling down now. So initially we thought that industries are the major polluting sectors, which is actually. So chemicals is something which is difficult to degrade, and these are not easy to degrade chemicals. There are textile industry wastes, dyes, pigments, and when these pigments get into the river water, they will give a tinge to that, and that creates a problem. So initially we thought, why not we should degrade the color. So if in a whole industry sector, if I take just color as a parameter, there are so many parameters: COD, BOD, the TDS, TSS, color. So color is, I think, something very important parameter which is having a huge opportunity right now in the industry, because there are industries who are able to reduce their COD, which is the chemical oxygen demand. That is a parameter where we measure the chemical nature of the water. More the COD, more chemicals are present. So color is something where we started thinking about the problem, because it's psychological also. If you go to your friend's place and you are offered a glass of water and it is having even a tinge of color, you will not drink it, and there is no explanation that why that water should have a color. If there is a color, that water is not drinkable. It's simple. But if you want to drink sharbat, or if you want to drink a cold drink, so in that color is fine. We can still see, we can still imagine that why there should be a color. But as such, the drinkable water, the first and foremost parameter is it should be crystal clear water. So we started targeting the pigment companies. So in Nagpur MIDC, we actually visited a nala where red color water was flowing, and from there we collected some soil samples. Those soil samples we processed in our R&D facility in Vasai here, and we found that there are actually some bacteria which are growing in that sample, which meant that they were able to eat that chemical, because they are living from like a few tens of years there, and they are pretty well accustomed to that background, or that environment, I will say. So we isolated those organisms and then we fortified them, and then we supplied the same organisms to the industry which was doing that, and we were able to degrade like 70-80% of color, and the problem was solved just by using the biodegradable matter which we or bioremediation should be the better word here. So just by using bioremediation, we were able to solve 60 to 70% of color reduction. And in the tertiary treatment, where they use carbon filters and sand filters, almost 90-95% of the water is being cleaned in that industry now. So with that, we started exploring this opportunity in textile industry, in pigment industry, and that's where we began thinking about this problem. So this is one opportunity I'm talking about. So you can imagine how big the opportunity is. So some sources, there are some reports which you can always search. So they say it's a $5 billion opportunity, but I believe that number is a little bit less, according to me, because when we talk about water and water treatment technologies, there are very ancillary parts also along with that industry. So for example, the water distribution networks, if you add that, the industry will become even bigger. Now if you add just the analytics part, there are industries, big industries, which are willing to do the analysis of their water. So water analysis is another huge industry. So if sum total, the ecosystem, if what I'm observing, I think it should be easily more than $20 to $30 billion market right now.
Got it.
Scale.
Yeah. So I mean, just on that point. So your secret sauce or your core strength is ability to isolate bacteria from a specific environment.
Yes.
Fortifying it and creating it at scale, like maybe some kind of a solution or something in which that bacteria can be sprayed or used in that environment, and then
right.
then nature takes over, right? Bacteria, they multiply on their
Right.
own. You don't have to do that. Okay,
Right.
great. Okay, got it. Yeah, so the first opportunity is essentially you talked about, what kind of business opportunity is this. So what are the other opportunities or other trends which you are seeing in this area?
So another trend which I saw recently was there are STPs which are already installed in many societies. In any metro city, if you go, if there is a huge building of more than 100 residents, so generally they have a STP installed on the lower basement. And what I am seeing is something very shocking, that is any 2 out of 3 STPs are dysfunctional. I think probably you should check your apartment as well. So there is a huge opportunity there for the refurbishment of these STPs, because this is driven by the policy and the scarcity of drinking water and reusable water. Recently, we saw in Bangalore that situation was very tense. The water was not available and people were actually shifting to their hometowns and they're working from home. So I have some of my friends who actually left Bangalore for 4 months. They came back to the town and they were working from home. So this kind of situations are driving the policies where now government is a bit more strict on giving even the licenses to make buildings. They should have a very good STP and that STP should be functional. So we are currently working on I think 4 to 5 such projects where we are actually refurbishing a STP. There is already a STP, but it's dysfunctional, and there is a refurbishment. So that is the one opportunity, which is a huge opportunity. How huge? So currently, out of 30 million liters of water which is spent every day, so we have only 20% of water which is being recycled using STPs. So the STPs which are there, they have to be refurbished, and then there is an opportunity of extra 80% which is lying there. I think that's the reason the Swachh Bharat Mission 2.0, they had a budget of around $18 billion for a single year. So that's the opportunity which lies there. Then secondly, so recently I will also give you a very interesting take. This is also related to water and waste management, but completely different. So we were the winners of DRDO Dare to Dream Prize, that 2021. And so out of around 10,000 applicants, we were given the first prize, and we were also now promised a ordnance factory contract. Now the problem statement was very interesting. So the problem statement said, and I'm talking about the defense industry here. I mean, sewage related, water related to the defense industry we are talking. It's that cross-functional nowadays. So they had a problem statement where they asked for a sustainable solution to treat water and soil which is affected by explosive chemical production and explosive testing. So a huge amount of soil is affected when the explosives are tested or they are dismantled. So whatever TNT or RDX is used in on the front, that comes back when the expiry is finished, and that has to be burned. So when that is burnt, that actually degrades the soil there where they are burning, and consequently they have to produce more. So there are explosive industries, and because of which a lot of water pollution they are concerned about. So this is one big opportunity which is related to government and also to the industry, but explosive industry. So that is one thing. Yeah. And other things which I saw is related to plastic pollution. Now there are one instance I will let you know. So we were doing a CSR work in Thane. So we said okay, we will provide bioremediation solution to treat a patch of nala. We selected that. We treated 30 days. We worked there, 30 to 60 days. But then what happened? I saw a heap of plastic being settled there in summers. Right. So it's in tons now. So whatever work we did at that time, that got a hit there, because the plastic which is coming through the nala, when the water dries up, is actually sitting there, because of which the nala water is getting septic. So plastic pollution is having a multi-dimensional issues now. Plastic, one thing is that it is plastic, it is going to do whatever damage it will do, that is there. And other thing is, if the surface is covered with plastic of small bodies, small lakes, that lake water is becoming septic. Septic means there is no oxygen inside, there are anaerobic conditions, and the aquatic life may not thrive there. So first of all, to remove plastic is one opportunity, and then to re-aerate that pond is another opportunity. So currently we are doing that in one of the lake, where we actually want to remove the plastic, as well as we want to reuse that nala water for repurposing. So this we are doing under Amrut Yojana. So we are one of the recipients this year for Amrut, where we are working with a municipal corporation, and this is a very interesting problem actually. So we are cleaning a nala here again. So our plan is to clean plastic as well and reuse that nala water. The nala water which is flowing through, it's in few million liters a day. You can imagine what impact it can have if that nala water can be reused. I am talking about just one nala here. So reuse of nala water is a big opportunity, and anybody who can crack that will be able to exploit that opportunity like anything.
Got it. So just a small query. When you say plastic, so do you mean to say you have identified or isolated bacteria which will eat the plastic? Is that what you're doing?
No. So I will give you a very frank answer here. So currently the intelligence or ability of the biology to remove packed carbon atoms is not that much. This evolution is going to take some 200 years. More than that. It's not just 200. It should be in 1,000 years. Biology evolves, right? Right now, there is no organism which can eat plastic. Even if it is able to do that, it is very slow. So here I will be unlocking a new opportunity for our viewers, that this problem of plastic is already growing, and it is responsible for hampering our resources on a very large scale. So whenever the regulations are a bit you can say loosened, if the genetic engineering or genetic modification of bacteria is allowed in water treatment industry, which is currently not. You cannot use a genetically modified bacteria. It has to be a grass grade, natural grade, and non-pathogenic. These are the regulations for any bioremediation currently used. So that opportunity is coming up now, because the way the plastic pollution is moving, I think that there will be this regulation which will say, okay, if you have a genetically modified bacteria which can actually eat plastic, then please do that. So that opportunity is coming up. We are not able to find such bacteria till now, and it's a bit difficult. It's a huge R&D process which will be required. But we are working on that. That's for sure.
But there were some reports which say that some bacteria which convert plastic into some enzymes have been found in Japan or some other place.
Yes, that is lab scale, and that process is very slow. That is the problem.
Okay, got it. So here
it should be in fewer.
Yeah. Sorry. So another point which I'm sure you must be asked a lot. So do you focus only on water or even solid waste? Because one other thing which I'm sure all of us kind of see is mounds of garbage in landfills, right? And what I'm told is, landfills kind of just generate methane, and it becomes a dangerous situation also. So if there is way of, kind of accelerating that, and that would be safer. So do you also work on solid waste problem?
Yes. We are also working on solid waste problems. First and foremost is sewage waste, which is a huge resource of making biogas. Interestingly, this is already being practiced in European countries. So currently, there are many European countries where sewage waste, which is generated in public, that is being booked by the companies who generate biogas for next 4-5 years. For example, Denmark. So in Denmark, they use this energy for heating purposes. They actually reuse this waste, sewage, which is a solid waste. Basically, we are talking about solid waste, which will be converted into biogas. So this is already being practiced. I am pretty sure this will be done here as well. Here also we are going to do that. Even we have proposed that in our couple of proposals recently. And another thing is there are some chemical industries which produce waste biomass. So that also can be reutilized. Just for example, in brewery industry. In brewery industry, a lot of waste yeast biomass is produced, or spent grain. They say spent grain or spent yeast. It's a bottom side what you get, and that smells, but that is very much protein rich. So if that can be reused, there are a lot of products which can be actually made out of that, and that R&D we have done in our lab currently. It's on lab scale, and we are talking with such companies who will be interested in such circular economy profiles, or if companies are interested in getting green credits or carbon credits which they can earn out of this. This will also prove to be another revenue stream for them, and it may also earn them some carbon credits, which is becoming useful nowadays for exporting out of India, especially in Europe.
Got it. So just out of curiosity, so when you kind of do sewage or waste management, I'm sure there must be a lot of minerals and other similar stuff which can be recovered and can be used. So is that a right way of saying that it's not a very economical way?
When we talk about biological degradation or bioremediation, so we may not be able to recover that mineral, because then you need some physical processes as well. But what can be done, if a resource is having particular minerals, so that mineral can become a medium for a particular bacteria which emits enzyme, and that can be applicable in different sectors like pharmaceutical sectors, food industry sector, biodegradable dyeing sector. That can be done. But minerals as such, they cannot be directly recovered using bioremediation. For that, you will need a physical processes. There are different membranes which people have worked on, which will trap those minerals or trap those heavy metals in that.
Got it. So here, when you look at impact, right? So I guess the impact will happen only when you work at municipal or city level sewage treatment plants. So are you already working at a city level in which you're kind of helping to clean the wastewater? And if so, if you can share some use cases and the impact what it has created.
So currently, as I said, we are into Amrut Yojana. That is, they select companies all over India and they attach us to a municipal corporation. So currently, we are being attached with Mumbai, and our work is currently going on to look for if there are possibilities to clean Nala and lake. So there are small lakes. You might have gone near Bandra. So near Bandra station, there is a lake, but in that you will see a lot of algae material in that. So how to clean that? So in that way, we are working with municipal corporation, and that project is underway. And before that, we worked with Thane, as I said, under CSR. So we helped them to devise strategy to clean Nala, and we showcased that for 3 months. But only what is my observation here is, along with the technology deployment and money which is being splurged on this, along with that, I think public awareness is also necessary, because I have seen this at many places where we were working. People were actually throwing their garbage in the nala in front of me. This has happened, and when I confronted somebody, why are you throwing this into the nala? So the answer was, then where I should throw. So along with technology deployment and all, the public awareness and public participation is very much necessary, because if I put my bacteria in a trench in some nala, but if people keep on throwing plastics, so it will get flown away after some time. So that is I think one factor which I would really like to see happening in upcoming days.
Yeah, can you share any before and after scenario? For example, the quality of water before your treatment and after the treatment. So that's the kind of will give a sense of what is the impact.
Okay, so recently I will give you a very recent example. So recently we have placed a water treatment system on the banks of Paneri River, that is near Palghar. So first it was very much turbid. The whole river is corrupted with the red colored water. So I don't really want to comment on is it from industry or is it from public. That we all know from where it is coming. But it's the river bank is in a very bad shape right now. And so we said, okay, let us demonstrate our technology. Let us see how we can clean that water, and at least it can be reused. So right now I don't have any photos of that, but we could convert a black looking water into crystal clear water, and the parameters were usable for the parameters which we got into treated water satisfied the norms where they can actually reuse that water for gardening, flushing, cleaning purposes. Definitely not drinking purposes, because for that another huge setup will be required. So that is a very recent example.
Got it. You talked about drinking water. So all these technologies, how can it impact availability of drinking water per se? Because that's a very pressing problem for humanity, right? And you're already running out of drinking water.
Right. So see, now there is a concept now here. So a few hundred years back, when there was no concept of STPs or CETPs or whatever, we just used to have drains. But even then the rivers were good in shape, right? That time, when there was no STPs, that time also rivers were good in shape. But then what is the problem for today's generation? So currently the influent which is going in is having chemicals in that. So rivers are not capable of degrading that. Rivers too have, or water bodies, natural bodies, they have an inherent capability to treat water. That happens in their bed itself. But we have to treat the water to that extent, after which the river is capable to treat itself. So that's where the parameters come in. For example, BOD, COD. So currently COD should be less than 50 milligram per liter, then BOD should be less than 10 milligram per liter. So all the sewage water which we use will finally go into some river or some lake or into some ocean. We cannot really make it into drinkable instantaneously. I'm talking about very instantaneously. It will take time. What we can do is to treat it in such a way that when we are discharging it out into some river body, that river body is not burdened with the chemicals. That has to be taken into account. And after that, I think after 5 years, 10 years, those water molecules will be regenerated and they will be repurified by the internal system. That's all we want to do.
Got
But
it.
if that also will not happen from industries, then there is a problem. And that's what is happening currently.
So essentially, I think the approach what you are taking is one city by at a time, and industrial area or water polluting
Industrial
areas
area.
at a time. That really kind of
Yes.
goes to the root of the problem. Great.
Yes.
Thanks, Atharva. This has been a wonderful conversation and really gives a great perspective. And thank you, dear listeners, for tuning in. Do subscribe, share, and like this podcast. Consider giving the podcast a 5-star rating if you like the content. Bye for now. Talk to you soon.